Find the coordinates of the points of intersection of the line y equals 4 minus 2x and the curve y equals x squared plus x. Okay, let me rewrite these two functions as y1 is equal to 4 minus 2x and y2 is equal to x squared plus x. Now, at the point of intersection, the value of these two functions must be equal. So this means that at the point of intersection, y2 must be equal to y1. This implies that x squared plus x is equal to 4 minus 2x. So we bring like terms together and write this as x squared plus x. We add 2x to both sides of the equation. This will become plus 2x, and we subtract 4 from both sides of the equation. This will become minus 4 is equal to 0. And so we have x squared plus 3x minus 4 is equal to 0. This is a quadratic equation which you can solve by factorization, and the two factors are x plus 4 into x minus 1 is equal to 0. So x plus 4 is equal to 0. Subtract 4 from both sides. X plus 4 minus 4 equals 0 minus 4. X equals minus 4. Or x minus 1 is equal to 0. We add 1 to both sides of the equation, and so we have x minus 1 plus 1 equals 0 plus 1, and so x equals 1. So we have the x coordinate of the 2 points of intersection. This shows, since we have these two values, shows that the line and the curve intersect at 2 points. Now we have to substitute this x equals negative 4 and x equals 1 into one of the original equations, either y equals 4 minus 2x or y equals x squared plus 3. I'll substitute it into the first. So when x equals negative 4, we'll have that y is equal to 4 minus 2 times minus 4. This is equal to 4 plus 8, which is equal to 12. When x is equal to 1, y is equal to 4 minus 2 times 1. This is equal to 4 minus 2, which is equal to 2. Therefore, the coordinates or the line, the line y equals 4 minus 2x and the curve y equals x squared plus x intersect at -4 or -4, 12 and 1, 2. So these are the coordinates of the point of intersection of the line and the curve. All right, thank you.